Hello friends, welcome to our channel Knowledge Amplifier. So today we are back with another video tutorial related to Snowpark, which is one of the very powerful feature provided by Snowflake especially for those data engineers who are comfortable in writing programming using PySpark, right? So today what we are going to discuss in this video, that suppose you are having some Parquet file sitting in external stage location, how to read them in a Snowpark data frame and how to write that data frame in a Snowflake table. On that we are going to discuss the coding part with concepts today in this video. Okay. So here what I will do, I will open terminal and I will launch Python in it. So here I have entered in Python shell and let me show you the external stage first. So here in my AWS account in S3 ID setter there is a bucket name. And within that we created a folder Parquet Dataset, and this data is basically having one Parquet file which is containing that IDs dataset Setosa part only. Okay, as we know that IDs dataset is a very popular dataset which is having characteristics about our IDs flower, sepal length, sepal width, petal length, petal width and class. So there are three different classes available: IDs Setosa, IDs versicolor and IDs virginica. Out of that I just took the IDs Setosa part and I created a Parquet file, okay, from the CSV data. So how to create Parquet file from CSV file using Athena, I already discussed in my previous video. I used that particular concept only. If you want to know that detailed explanation, you can check the description box. Okay. So here what I will do now, we already having our Parquet file. We will go to Snowflake, and for this particular demo, I will create a fresh database ramu. Okay. So here these three codes I am executing. Now here what I am doing, I am creating an external stage without any file format. So all the files basically it will be showing if we are using list command. So here you can see that it has written this particular file which is our Parquet file sitting in external stage, right? And parallelly let me duplicate the console and let me go to query history, because that will help us to understand what is happening in backend when we are applying data frame operation. So here you see the latest command what we have executed, that is list@ramu.public.snowsample. This is basically our stage name. So that particular command it is displaying. So here we can have a track that what are the queries getting executed in backend. So here list command is done. Now as a next step what we will do, we will load that particular Parquet data in a table called Parquet override. Okay, so let's start from Parquet override. As of now, if I execute this particular code, obviously you will see it will return that it does not exist, because just now we created this database, we have not created any table. So that's why it is showing like this kind of error, right? Now let's go back to our Python code. So here first step what we are doing, we are inputting all the functions, types and Snowpark session. Okay, that is done. Now here we are creating our connection properties. User ID, password I have not given, I will provide that, and I will execute this particular part. So I have already provided this particular user ID, password and connection parameters. So now if everything is correct, then this connection setup should happen with Snowflake. Okay. So let's see, the session got created successfully. Now what we are going to do, we are going to read the Parquet data. So Parquet data is available in external stage. So the only way to access this particular file is provide the external stage. Okay. So ramu.public.snowsample, we are providing the external stage name. Basically this particular external stage, if you see, it is pointing to that particular location only where the Parquet file is sitting, right? So here let's try to read the data. It is same like how we did in PySpark, spark.read.parquet. Similarly here, session.read.parquet. That's all. Okay. So here I will execute this one, and here it is done. Now let's go back to our this particular query history and let's see what queries it has executed in the backend. Okay. So here if you recall, last query we had executed in the Snowflake console was select start from Parquet override, right? Which thrown that it does not exist. So any query which is appearing after this particular one is due to this particular file read, right? So here see, select start from Parquet override is available here. So basically these three set of queries are executed due to this session.read.parquet. Okay. So what are the codes executed? Let's try to understand. So first what it is doing, it is creating a temporary Parquet file format. Okay, fine. Now if you recall our previous video, while reading the CSV data from external stage, we had to mention the schema. But while reading Parquet file, we are not doing that, but still it is not throwing error. Whereas in CSV read case, if you are not providing schema, it throws error. Why such differentiation between CSV and Parquet happening? Because in Snowflake, the infer schema can automatically detect the schema for our Parquet file, right? And that is basically happening in the backend. If you recall our discussion on infer schema, which link I'll be providing in the description box also, you can clearly understand that using infer schema, you can detect the schema of the Parquet file, right? So we are not mentioning the Parquet schema. Using this particular code, Snowpark is determining the schema, and then after schema detection, it is basically dropping the temporary file format, whatever it has created. That's all. Okay, right? So here, if you want to check this schema is detected properly or not, you can just execute this particular command. It is just like in PySpark how we use print schema, like that. Here you can use dot schema to check this schema property. Okay, so here you see ID is long type. So if you recall our previous video, ID was basically an integer type. Okay, and then here sepal length, sepal width, petal length, petal width, all are double type, and class name is string type or varchar type. Okay, so this is what this schema is detected, which is perfectly correct, right? Now here what we will do, due to dot schema, you will see that here no new query got executed, because from the DataFrame property itself it can be fetched. No need to execute any Snowflake query newly. Already this particular select star from table infer schema was done, right? So due to that, the schema also we can extract as a property from the DataFrame. Okay. Now I will do iris flower read dot show. But before that, here let me execute this particular code again. So here if I go back to our query history, here we can treat this particular select star from Parquet viewer as reference query. So any query appearing after this particular code is due to that dot show command. Okay. So let's execute dot show. Just check that whether data is properly able to read or not. So here see that the data is coming properly in our data frame. Now let's see what are the codes got executed in the backend. Just refresh the screen, and here you will see that it is same like earlier while reading CSV data. That first step, it is creating a temporary file format of Parquet type, and then here it is reading the data, select star from. So $1 is basically variant data type in Snowflake. As you know that Parquet data, complete data will be coming in this particular column. From there it is basically extracting individual key and then typecasting that to proper data type, and then here it is giving the alias name. That's all. So this is the set of queries which is getting executed in the backend, and at the end it is dropping that temporary file format, right? So here I hope dot show is clear to you. Now here what we'll do, we will write the data in Parquet override table. So again let me execute select star from Parquet override to treat that as reference. So here you see select star from Parquet override is there. Again it failed because the table does not exist. So any query appearing after this particular one is due to this particular code. So it is same like what we discussed earlier. To write the data, you can simply use save as table. Okay, and here in the mode you can mention that it should be override mode, because now we want to override the table. Okay, right? So here it is done. Now here let's refresh the query history and see here. First it created the Parquet file format, then it has executed create or replace table Parquet override. Okay, so basically it is creating a permanent table with the name Parquet override, but here it is using create or replace command. Why? Because here we are writing the data in override manner, right? So if the table is existing, it will replace that. If the table is not existing, it will create that. Okay, as simple as that. And then here what it is doing, it is selecting the data based on the same query what we have observed while using dot show. Okay, and then here as a last step, it is dropping that temporary Parquet file format, whatever it has created on the fly in the first step, right? So this is very simple. Now let's go to the append manner writing, and here what we will do, we will try to observe another interesting part. That is, earlier we have seen that if the table does not exist, append manner or override manner, whatever you are using, first it will create the table. Now next time onwards, if you are using override manner, it will always replace the table. In case of append manner, it will check whether the table is existing or not. If the table is existing due to first time creation, from second time onwards, it will simply insert the data, right? Now suppose instead of creating the table using Snowpark, if the table is already existing beforehand in Snowflake, then how it will behave? Let us try to understand that part. Okay. So here what we are going to do, we are going to create the table using SQL query first. So here you see I have given the same schema ID, sepal length, sepal width, petal length, petal width, and class name with proper data type, and I will execute that. And now let's execute select start from video 1. As of now it is empty. If we go to query history and if we refresh, here you will see select start from video 1 is the latest query. Any query appearing after this one is basically from Snowpark. So here what we are doing, we are writing the data in the video 1 table which is already existing, and that table is not created using Snowpark. That table we created using Snowflake SQL query. Now let's see whether in that table the append manner data can be written or not. Okay. So here what I will do, I will execute write. So here it is done. So let's see in Snowflake query history. So see, first it has created the Parquet file format. Then here as a first step it has checked whether the table is existing or not. Because the table is already existing, it is just inserting the data in the video 1 table. And the select query is same like earlier, no change. Okay, right? So now if I execute select start from video 1, here you will able to see that the data related to ID Setosa is coming properly. So what I mean to say using this particular experiment is that it is not like always the Snowpark need to create the table. Sometimes it might happen the table is already existing in Snowflake beforehand. Now if you try to append the data in it, Snowpark will insert that data in that table, no problem. Okay. Now let's see the next case, that suppose the table is existing but it is having some unnecessary column in the middle which our Snowpark DataFrame is not having, and then we will try to write the data in that particular existing table using Snowpark, although schema is not matching, and then we will observe what is happening. Okay, right? So here what we are doing, we are creating another table video 2. Earlier we have seen already, right, that ID, sepal length, sepal width, petal width, and class name. These are the columns for our data frame as well as table. But this time while creating the table, here I added a dummy column of double data type. Okay, and then from Snowpark data frame we will try to insert the data in the video 2 table and we will observe what is happening. Okay, right? So here let's do that. So here see it is empty. Let's go to query history. Let's refresh the query history. Latest query, select start from video 2. Now using append manner we will try to insert the data in this particular video 2 table. Okay, so here see this is the query. Although in ID's flower read the schema is, if you observe, ID, sepal length, sepal width, petal width, class name, but in the table where it is trying to insert the data in append manner, there an extra column is there. So let's see what happens. So just execute this particular code and see it has thrown an error. What is that? Insert value list does not match column list expecting 7 but got 6. Okay, so what it is trying to say, you are basically inserting in a table with 7 columns but you have only 6 columns in the data frame what you are inserting. So obviously the query got failed. Even if you refresh the particular screen in query history, here you will see first step, it has created the temporary Parquet file format. Then it tried to execute this insert query, insert into video 2, select star from, and it took the data from $1 variant column in Parquet file, and then it tried to insert, which obviously failed. If you click on this particular query, here also you can see that error, insert value list does not match column list. It is expecting 7 but got 6. Okay, so the problem we understood. So now let's try to understand in this kind of case what is the solution. The solution is, when using save as table, you can mention a property column order. So generally what happens if you are not defining the column order property, it tried to insert the data column by column in order. Okay, but suppose you are mentioning column order equal to name, then what will happen? Suppose in ID's flower read you have ID column, sepal length, sepal width, petal width, and class name. Whereas in your destination table, that is in video 2, suppose you are having ID, sepal length, sepal width, dummy column, and then petal length, petal width, class name. It will map column by column. So data frame's ID column will be going to video 2 table's ID column. Data frame sepal length column will be going to video 2 tables sepal length column, like that. Now the data frame is not having any column with the name dummy column. So what will happen after inserting the data for those rows in the dummy column, the data will be null. As simple as that. Okay, so this is the importance of column order. So let's execute the column order and let's see what is happening in backend. So here I have executed. So we got another error. I will come to this error, but before that, let us try to understand what is happening in the query history. Okay. So the last query executed was this one, drop file format. So let's refresh this screen now. So here see, this was the reference query, after which all these queries are due to this particular command execution. So what are the queries it has executed? First, it checked whether video2 table existing or not, because we are trying to write the data in append manner, so it is doing that check. Fine. Then here what it is doing? It is basically creating that temporary file format with Parquet type. Now here see the beauty. Earlier the insert query failed in video2 because video2 is having 7 columns, whereas our data frame is having 6 columns. Okay. So what we can do? Here we can mention what are the columns where we need to insert the data, right? That is insert into video, then within parentheses we can mention the column names. That's what the column order equal to name, that property is doing. See here the query change, insert into video2, id sepal with petal with class name. It is not considering the dummy column because dummy column is not existing in our data frame itself. And then it is trying to insert the data, whatever it has selected from the external stage. Okay. This way, the issue of column number mismatch is resolved in between our data frame and the destination table. But now we got another exception, and that is invalid identifier ID. So what is that? So here see the video2 table, when it is trying to insert, all the column names are enclosed with double quotation. Okay. But in our table, the column names, if I execute select start from video2, they are not enclosed within double quotation. So that's why the problem is happening. It is telling when it is trying to execute this particular query that ID with double quotation open, double quotation close, such column does not exist. And that's why it is throwing invalid identifier. So now the question may come in your mind that why the ID column is having double quotation or all the column names are coming with double quotation, right? Because here we are not providing. So the reason is, if you observe our data frame dot columns, if we do, here see, in the data frame itself, all the column names are enclosed with double quotation. That is the problem. And that's why when it is executing this particular insert query, that time also it is thinking that in the destination table also the column names will be double quoted. Okay. So there are two solutions. Number one possibility is you create the video2 table with the column names having double quotation in it. That is ID int. Then here you can put double quotation open. Then here sepal double quotation. Like that, all the column names you can configure with double quotation, and then this particular insert query would work fine. But that is not the correct case, right? We never mention the double quotation generally in column names. So the another solution is just rename the columns properly. Just remove the double quotation. So for that, I have done the same. That is, I have used the with column renamed property, which you use in PySpark also for changing the column name in a data frame. So here, all I am doing, that double quotation I am removing with the normal name. As simple as that. And for all the columns I am doing that activity. So that's why here I am using this many with column renamed. Okay. And then I am writing the data in video2 table. So let's see our video2 table data as of now. So till now it is empty. And now if I execute this particular code, here you will see that it is done. Okay. Cool. Now if I do select start from video2, here you will see that ID sepal with petal with class name. Whatever data is available in our data frame, for all those, the data are coming. But dummy column, this is not available in our data frame itself, right? That's why it is having null data. And although some extra column is available, but still write operation is getting successful because the data we are ingesting based on the name similarity between the Snowflake table and the data frame columns. Okay, right? And now if you check the query history, you will understand that due to the with column renamed, what happened? See, earlier insert query you observe, when we applied column order equal to name, that time the double quoted column names were coming, which was causing the problem. Now, when we have renamed, that time, see here, insert into video2, in what columns it is inserting, that columns are coming without double quotation. That's the beauty of with column renamed. That way, using Spark concept only, you can solve 99% of Snowpark issues, because this is a very common problem in PySpark world, right? That changing the column name. So we are using with column renamed. First we are providing the older column name which is existing before the changes, and then we need to provide that with what column name we want to replace it. That's all, and that way the code is working. So just try to play with this particular code. I'll be sharing the file as well as code in the description box so that you can parallelly practice. Just explore more from the documentation as well. I'll be sharing the documentation link also. So if you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. See you in our next Snowpark discussion. Thank you.